Well, I brought some work home with me. I knew that I had to order parts for this furnace for a customer of mine that's kind of far away, over an hour away. So to save some time, I bought the furnace home, ordered the parts, which have came. Let me get it. This one needs a motor, blower motor. That's what we're going to be changing out today, guys, doing a blower motor. So I stopped and said, well, let me make a video for this. Some of my new techs might want to see this. So the only thing I've done is I've removed the unit from the case. And some of them will pull right out. Other ones, if it has this plate on the side and the lip goes to the outside, there'll be two screws holding that plate down. That's going to prevent this part from coming out, so you have to remove that plate. So I have my go bag. This is my diagnostic bag, and I got my magnet out of there. This is just one of the hold down brackets that was on the case that goes into the floorboard of the camper. So what did I do next? Well, this comes like this, and this wire is always in the way, so I always just cut it and put a Wago on it. I reconnect it later with a Wago. Makes it easier to work on it in the future. The cell switch on this one you can get to without taking this off. But yeah, so I just snipped the wire for the blower motor, which is getting changed out anyway. So it would have been getting kind of cut. I could have just pulled it through, but I didn't want to disturb the zip ties. And this furnace is only a year old, guys. I don't know what they're doing with this stuff. You know, the manufacturing, maybe you just got a bad one. But yeah, these wires, and I'll be cutting the black one too. They're already on the new motor. So, and even if I wasn't changing out the motor, I still cut those wires. I cut those wires because it makes it easier to work on the ones that have like the cell switch inside. You got to take this off to get to the cell switch on some of them. It's not like right there. And when there's a wires in the way like that, I just snip it and put a Wago on it on the way back. So now we can see what we have here, guys. And we can get a good look on the screws. Don't try to do this while it's in the camper. Always take your furnace out, bench test it when you're having a problem with it, you know, and you think it might be this, you think it might be that. Bench test it, take it out. You should have it set up like I have, with a small propane tank, battery, you know, the hoses and everything, so you can connect this thing up and work with it on the bench. That's how I was trained as a dealer tech to do it, and that's how I do it as a mobile tech. The other thing that I have taken off that I didn't tell you about is the control board. So because I did that at the customer's house. So the control board wires are over here. I've disconnected the control board. It's on a little plate. It kind of just slides in right here. So the control board is off of this unit, and I forgot about that because I did that while I was diagnosing this at the customer's house while I was bench testing it there. I took the control board off, and I have it in a box in my truck. So, but yeah, so now we're gonna take this apart. See, there's a screw there. All right. So we have this screw, and we have this screw. Let's see if we have any others. And then it kind of has these snaps. Be careful, try not to break these. I'm gonna stand this up, see if we have any other screws. Yeah, looks like that's it. Just those screws. There is a screw over here, and over here. See, the motor's in the middle and it's turning two wheels. It's turning this one to push the air in the unit, and then it's also turning this other wheel. So it has like an intake wheel and an exhaust, kind of like an air conditioner. So two shafts, it's two little wheels. So you kind of got to take the whole thing apart. Take this clamshell off, and you can see inside there. There's one side of your motor. The other side you can't see until you open this up. So there's a little screw there. So just make note of where all your screws are. Don't try to force this stuff. Just easy does it. And let's go. So I'll be starting to remove my screws and put them on my little magnetic pad as I go along. All right, guys, so this is a Suburban furnace, 42 VHFQ. Like I said, this furnace is only like a year old. So this is like a 2023, 2024 model. And on this one, out of those screws I showed you, you don't have to take out the mounting screws, because when I showed you the clips, this clamshell is like a clamshell. That's what you have to take a loose. And you got to be really careful. There are two screws that you have to remove, okay? And these are the two screws. So these two fasteners, one goes in this corner. The other one goes right here in the middle where the igniter wire is going into the burn chamber. So this is what I use. You can use whatever you have or whatever. But I'm using a little small pry bar that I broke the clip off a long time ago. So I just keep it in this bag. It was a Mac Tools. It is a Mac Tools, but it has a really thin head, which is why I like it. And I just pry under. You know, it has the slots in here to where you see how you can flex it out. Just be careful with that. And as you're doing that, you're kind of like taking your hand and putting a little pressure to create a crack. Then I take a sheet metal skinning tool. You can get them off the truck made by Blue Point, or you can go to Middle Magistry on Amazon and get it. And then I kind of just kind of wedge it and just kind of lift up like that to make the crack as I go around. There was a screw right here. There was a screw right here. Yeah, I believe it was. So, but it was only two. I don't think it was. There wasn't a screw. There wasn't a screw in here. I only pulled out two. One from here, I know for sure, and one from this middle section. Let me turn the light up a little bit. Give us a little more light. Yeah. So there was one in this middle section, and there was one right here. It looks like one could go here. I guess they have that, so if you break the clips, you can put a screw there. So I'm just going right under here, flexing that out. Let's see, like so, because it's only gripping on that little ledge there. And then I'm using my pry tool as I go around to lift up. And there you can see the little tab that it's grabbing onto. It's just a small tab. And just work your way around. Like, see here, there's no screw there either, but there can be one. And I think they did that because they know that people are gonna break the clips. So they spin this around on the bench. As you can see, you're not doing this while it's in the unit. You need to do this outside the unit. And you know, just take your little pry tool, pry that out to lift it up, and take your other pry tool and give it a little lift as you go around. And that's gonna get it. Now I like to go on the points like here, and it gives me a nice little leverage point. So let me finish doing the clips, I just wanted to show you that so you can know how to do this without tearing this thing up. The core, this is called a core. That's about between $500 and $600, you know, for the whole core. Which, for my customer, normally I just replace the core. I just tell them to buy a new core because if it's really old, but this one's really new, and since I have to drive like almost 2 hours to put this back in again anyway, I'll just do the motor because I was able to fund this motor for, I think with the next day air shipping, it was like $130. It was like $80, and then because of the next day air shipping, it was more because he wants it fast. So that's what we got going on. Let me go ahead and pop this out, guys, and then I will show you what we have when I take the clamshell off. All right, guys, so now that we have the clamshell open, all the clips are off, it's not going to come up. There's going to be a couple wires in the way. So I have this spun around. Remember, the igniter wire is kind of going through like this, and it's coming along the other side. And then you also have this wire was going through here for the cell switch, and then the igniter wire could be going through the same one, but they had it coming through this side. So here is where I was like, I snip the wire. This is where I normally snip the wire. I normally snip it in the front, so it's easier to service the next time. So, but because I'm doing this, and this is that wire. It comes all the way around and goes through the back to this grounding point. So for right now, I'll snip it, but I'll reroute the new wire to where it goes. So for right now, I'm just snipping it, and then you can see both of the wheels that I was talking about. What else has it? Oh, the other power wire for the on-off switch from the control board. Okay. And you have anything else holding it? Oh, it's like a they have like a little plastic stud here that it's like a plastic rivet that we have to pop out. It's keeping it from coming out. I just use my pry tool, and you see that rivet back there? Get that rivet out. Use a couple of pry tools. Looks like its only purpose is to keep you from taking this out. So I didn't take it all the way out. I just slid it back enough so that I can release the assembly here. So now it's out. For right now, we can just push that to the side, and yeah, this thing is making a horrible noise. The bearings are going in it. So let's see if you can hear it. Yeah, I don't know what happened with this thing. See all that, whatever that is. It was making a horrible racket and just wouldn't spin fast enough. It would spin slow, like the motor would spin slow like that. It wouldn't ramp up speed, and when it doesn't ramp up speed, it doesn't get enough power to close the cell switch. So that was going on, and sometimes it wouldn't start at all. I'd have to hand start it to get it to go. You know, just like in an air conditioner, when a capacitor is going bad, it kind of acts like that. All right, this is just kind of pressed in. These little pads on the side help it make a tight fit and hold it steady. You can see how it only can go one way because of the wires. You do want to inspect these wheels to make sure they're not missing any fins. That will throw it off balance and cause problems. That is not a defect. That hole there is so that you can put an Allen wrench in to hit that guy to take this wheel off. You have another hole on this side to accomplish the same thing. It's giving you access to this. Like, we have it all out and it's easy, but if this was not all out, it would be harder to, and even on this one, it'll be a lot easier to use an Allen key going down. But you can use the short side and still get it from this way as well. What I used to do on the air conditioners was I would use a 1/4 inch Allen socket with an extension. The hole is much bigger on the air conditioner, and I put the socket in first and then I put the extension through the hole, and it was easier to do it for ratchet, more power. So we need to transfer this onto the new motor and then put the new motor back. You know, pay attention to how you take it off. The short side goes with the little wheel, the long shaft goes with the big wheel. Okay, I don't even think it'll fit if you put it on the wrong way. Like, it won't line up. Everything won't line up. After we get this guy apart, we will bench test it. We'll bench test it. I don't think we're gonna do it in here though, the gas. I could, because it's just throwing exhaust and stuff, but I could bench test it in here. I didn't bring the other pipe with me, so I have to rig up something for that. But other than that, we could bench test it, because like I said, it wouldn't spin fast enough to push the cell switch close, and that's why this thing wouldn't work, because the motor has gotten to such a point to where either it wouldn't start at all, or if it did start with a hand pull, it wouldn't spin fast enough to push the cell switch. So it's just a bad motor. Don't know what makes the motor do that. Not an internal motor specialist. But let's get this thing took apart. Go outside cold and grab my Allen sets. Little small ones, maybe like a 2.5 millimeter. All right, I'll be back. All right, guys, so as I suspected, 2.5 millimeter. I bought both of my packs just in case, because I'm not always right. So we got 2.5. I'm using the Eklunds. They use a thread locker on this blue Loctite, and I normally like to use the snap-on ones, especially these style with this little ball end for getting in at a little angle, because that's a weak point, and I always feel like that thing's gonna snap off. I mean, but anyway, I used the L part to break the torque, so I went in like this, broke the torque, and then use the weak part just to run it out. This is a Chinese part, and that's what the original one is, the same exact Chinese part. And now we can take a look. Let me zoom out, give you a little bit of more clarity. May of 2022. So it's a 2023 camper. The furnace is from 2022. It's the beginning of 2025, so it almost made it to 3 years of existence, but it's only been used for a year. Okay, this one, as you can see, 2024 August, so at the end of 2024, this motor. So before I take the back wheel off, I'll just go ahead as I put this one on. It has a flat spot in there, Let's see if I can zoom in on it. So it can only go on the shaft one way, okay? So I'll put this one on, take this one off. A little easier to get to. It's got more hand room to pull the, they're on there kind of tight. This one, I don't see the thread locker. The other one had thread locker on it. I don't see thread locker on this one. And it's not as tight as the other one. So, and then after I get it loose, since we're not coming at a, there we go. Just loosen that up and that will come right off. And that's how you take these wheels off to do the motor replacement. To say that this is like a 42K BTU furnace, it's a tiny motor. They're just little motors. The motors aren't that big in these furnaces. So like I said, this only can go on one way. The shaft has a flat spot on it, so they can only go on one way. So I'll put these back on because I need two hands, guys. And we'll start reassembling this furnace and get ready for bench testing. All right, so I got this put back together. It just snaps back together. It has a little guide, like it has guides so that you go on straight. And so the next thing you want to do to make sure everything's fitted properly is spin it. You hear that noise? Something's hitting. So now I have to adjust this because, and it feels like it's in this wheel. So I loosen up the Allen screw and I'm gonna move this forward and backwards until I can get a, feels like something's hitting. Then I'll take my 12-volt battery after I think I have it positioned good enough. I'll take my 12-volt battery and run it and see how it sounds. But I'm not happy right now. I'll probably be popping this back apart because it's like I hear something hitting. There's something hitting. It's rubbing something. It might be on this side. Something might be hitting on this side. I wonder if it's that plastic rivet. Let me get that out of there. Yeah, I think it's that plastic rivet. Let me work on this. All right, guys, so let me show you how to repair something that may go wrong during this repair. I like doing this part because a lot of people don't show the mess ups. So you may recall earlier in the video how tight this set screw was with the blue Loctite on it. Well, as it turns out, when it came out, a little bit of the threads came out with it. And when I tried to tighten it back down, it got to a certain point and then it just spun. So I knew that that was not going to hold, okay? So what do you do about that? Well, it's time to go to the uh-oh kits. So I keep a bunch of these little kits from Harbor Freight. So I went out to my storage unit and I grabbed a pack of set screws. And I picked out one that was just slightly larger than the one that I had. So that was gonna be like a, in a fine thread, that was going to be like a 1/4 28, and in a coarse thread that was going to be like a 1/4 20. All right, so I went with the 1/4 20, very common tap size. And then I got this Icon kit, but before I tried it, I tried this little Irwin kit because it came with the drill bit. It came with the number 4 drill bit that you need. So I bought this as well, so I could know I had the proper drill bit. And it just says number 4 on the drill bit there, which was just slightly bigger than what was there, so it was a great choice. Now, as you can see, I have this 1/4 20 in here, and it is fitting quite nice. This will tighten down, and this is steel. I'm not worried about that getting damaged. I am going to put the Loctite on it, the blue Loctite, but I want to show you how I had to fix this because this is kind of difficult. I almost jumped on the truck, but I didn't want to pay, you know, $745, I believe, is a Snap-on tap and die set. And it doesn't, I don't believe it has, let's see, I don't know if it has as many pieces as the Icon set, which was out the door $150. So the Icon set comes pretty much as you see it. I have one of the tools out of it. I want to show you this because, like I said, it's kind of nice when people show how to fix stuff when stuff goes wrong. All right, here's a little tool. I don't know how I lost that. It's sitting right here at the table, but it's yeah, I had to get the twin grips out, and I had the high leverage Snap-ons. Didn't know which one was going to do the job, so I grabbed them both. And these are stacked, so like the dies are here, the taps are up top. I like that. It's more compact. There it is on the floor. So I started off with this tool because they give you that little hole in one of the fins to get the Allen key through. And so I took the tap. I tried to use the Irwin tap first, but the Icon tap was a little longer and a little stronger. And I'll show you what I mean. Like, so notice on the threads start sooner, so it doesn't have so much of a taper. And it seemed like the first ones in the beginning, they were just like, let's focus here. It's just like it was kind of just rounding them off. It was just beating it up on the Irwin. Maybe I got a fluke because Irwin used to make really good stuff, and I was going back and forth breaking the chips, you know, and I use a tap. But on this one, it starts cutting the real threads sooner, and that's what I need. This might be fine if you have a long distance of travel to where you can get all the way up here before you need it to start cutting the real threads. But look at the amount of space that I'm working with. It's only a couple of inches here, and I don't have far here to go down, and I need the real threads to start cutting pretty soon. So the Icon tap, it's much better suited for that versus the Irwin. So basically I ran the Irwin down, and the threads were not cut because of those issues. But basically I came down through here, got my tap started. Then I used this tool to start to tap in. I didn't have to go far because the middle's not that thick. So by the time I got to the point to where that tool couldn't be used anymore, I could see threads in here. So, and this had pretty much only had the top part sticking out. So there's nothing that the tool could grip it. So that's when I had to use my little Knipex to kind of grab it at the very top, spin it in a little bit, and then I switched over as it got halfway in. Then I went with the high leverage or the twin grips. They both work. These are kind of built for round stock more so than these. These grip and won't slip. The Knipex, they're just too short and they were slipping. But the twin grips, which are also Knipex, they grip the round stock a lot better. So these worked a lot better in gripping the shaft of the die. After I had it, you got to understand that it had already gotten halfway down this opening. So I wasn't worried about the tap not going in straight at that point. So yeah, so I finished it off with the Knipex, ran it all the way through. It tapped bottomed out the tap inside this little aluminum or steel piece, whatever it is, I don't know, I think it's probably aluminum. And then I backed it out and tried my 1/4 by 3/8 because I wanted a longer set screw than what was originally in there. And this set screw starts grabbing immediately, being coarse. So that worked out. So that's how I got over that hurdle so I can put this together. I also ordered another wheel, but like it's cold and the guy needs his furnace like now. He doesn't really want to wait. You know, I told him I could try to repair this wheel and get you going, or we could wait for the other one. He really wasn't trying to wait. He rather I did what I could do. So I spent a little money and got some tools that I can use on a lot of other stuff so that I can get this right for him with a larger set screw. So now we have a larger, beefier set screw to hold this to the shaft. And now I can go ahead and finish putting this together because that was a holdup. And you know, with the ice on the roads and the weather delays, and you know, everybody's using the excuse. So, and it's valid. You know, it's hard to drive when there's ice on the road, man. And those big delivery trucks, you know, nobody wants that. So I get it. So that's why I'm trying to fix this instead of just saying, oh well, there's nothing I can do. Well, there's always something I can do, you know, but I always gotta be upfront with the customer so they can know what's happening, what am I doing, what are the alternatives, you know what I'm saying, so they can make an informed decision. So he decided that he wanted me to try to fix this, so I spent the money to fix it. I also tried these DeWalt's. It wouldn't work in this application. You see the cutting tip, it's just too long. I don't have that much to play with. It would have just been a drill. It never would have gotten to the thread. So I do like these. This is great, especially for sheet metal projects. Like I said, when you got a lot of room and you can run it all the way down. But on something like this, I need a real tap, something that I can get in the close quarters with, and that's what works. So I don't want to mix these up. I believe this is my icon. I want to put this back in the kit. And, you know, it would be like $300 for the SAE and metric, but I only bought the one that I needed. I believe I have, either I have or I had some, I do have a Irwin set in one of my toolboxes. Maybe I have metric and Irwin from a long time ago. So I went with SAE because that's the size set screws that I had. And 1/4 20 is a very common thread size. So I use a lot of 1/4-20 stuff. I left this tool out. So yeah, guys, these icons did well, and I did not use them all the way in the way they're supposed to be used, and even putting the pliers on that the shaft, the steel is strong enough. It didn't eat it up or anything. It didn't leave a mark. Actually, it didn't mark it at all. So that's that. Now let's put this back together and bench test it. All right, so I found my thread locker and I had to go outside to my toolbox for that. Made a bit of a mess because you know, everything's frozen outside, so when I grabbed it, I kind of broke the top. No worries, I just stuck my Allen key in it, stirred it up, and have it on. I like to do this because if they had it, I want it because they had it on there for a reason. So we got our blue Loctite thread locker. It's not Loctite brand, it's Permatex brand. Spin, no noise. I'm gonna clamp it back together because the whole reason I took it apart was because it was a noise, possibly because the wheel was a little loose on that stripped out set screw. Now I have a good solid 1/4-20 set screw in. I'm gonna put this on top of here. This only fits one way. You can see the clearance, make sure we got clearance all the way around, and these little pieces make it tight, and this little pad anti-vibration. So now I'm gonna flip it over and install it on the top of the unit. I need 2 hands, guys. So I'm gonna just flip that over and put it on top of the unit. Okay, so before we go any further, went ahead and put the 2 screws back that I took out when I disassembled the unit. Have it all snapped shut. So double check here, making sure everything's put back together well. And now I'm going to test the blower motor. So I have one of my little Mighty Max batteries here, and there's my wife. And let's see, I'm using the AES Wave kit, guys. So everything I'm using to run the power, I told you guys I was gonna run power through it. I'll put this kit through its paces because it's like $300, and if I can't run at least 10 amps through it, it's not worth its salt. Because I mean, when you're doing current testing, even a multimeter can handle up to 10 amps on just about any multimeter lead. So this is the kit that we're using, the AES Wave. The components that I have out to make my connections, and this is super convenient because it has all the pieces. The number 6, so I have the 6 FLT-M, these red and black ones, and then I'm using their T leads, and then the 2 large alligators to make the connection to the battery. So I'll get my ground, put my power. All right, it's humming, guys, and I know that it's blowing strong enough because look at my sail switch. The other motor, I had the hand start it, and even when it did start, it didn't run strong enough to push my sail switch. So now that I know the blower motor is fine, no noises, no rubbing, everything's good, I'll go ahead and install the control board. And in this control board, it just kind of sits in here. Where was it at? It was back here somewhere. When I put it in the case, I could tell. Oh yeah, it was kind of like that. I could tell from the case because I got to cut out, because this is so hard to get to. It sits right there. I need to grind down those edges. So yeah, I'm gonna get this back together, hook up the control board, and crank it up. All right, guys, so here's how it goes. See those little feet on the board, slides in there. The dinosaur boards have those feet on it too, but on some of the older units, those feet keep the board from fitting, and you have to do some interesting things in order to maybe I'll get to make a video about that. But the way I handle it on the older units, where the board is kind of like under there, it's like in a little pocket, I take a soldering iron and I melt the nubs off so that the dinosaur board can fit in, and it works fine. Anyway, we got this one put back together. See, these two wires that we cut, didn't matter. They were part of the old blower, and we were replacing it anyway. All right, so you see where the board goes now, and we have all our connections remade, and the ground bus bar is under here. That's where the black wire from the blower motor goes. This black wire is for the cell switch. It's part of one of the proving circuits. There's a little schematic right there if it's not all rubbed off. This camper had a water leak, so I'm not surprised that this motor failed. It kind of shorted out a bit because on top of this furnace is you can see the burn marks there, and I seen some burn marks somewhere else. They had a water leak, and it's dripping on top of the furnace. So there you go. And you could tell because just look at the sticker. This is kept inside the unit. That's clearly water damage. So I bet your water was getting in there on that motor. You see it has a hole right there. It goes right to the electronics. Those are the power leads. So yeah, this is probably related to the water leak. So I'll make sure to notate that on my report. But I'm gonna just slide this back into the case. I'm gonna go outside while we still got a little daylight and bench test this really quickly with gas and everything. And let's see if we can get the customer warm again. All right, we got it back in the case, ready to go outside and bench test. There is a screw that holds the core into the case. It's right there. So if you're having a hard time getting this off, especially if you have not removed the back plate, two things you want to look for: the gas fitting. If it's like this, some of them, the gas fitting is up here and it's like not in the way. But this screw, most definitely, you have to take the back plate out to get to that. I take it off anyway because there's 3 ducts connected to it, and it's easier just to move that screw and that screw instead of fighting to get it back on. When it's time to reassemble this in the coach, it's easier just to put the whole plate on, and then I'll just fight with these 2 little twist lock mechanisms. So yeah, yellow is ground, red is power, the 2 blues are thermostat. Let's go outside and bench test this, and let's see if we can't get this back to the customer. All right, time for bench testing. Get you a fully charged battery, make sure it's charged up good. Connect your negative and your positive. Got our thermostat ready to go. Next, we're gonna connect our gas line up. If you don't want to use your test tool, you can just buy one of these 1/2" to 3/8 double swivel connectors, and you can just go quick and dirty straight from the regulator. So I'm just gonna connect that. Because your furnace is gonna be 3/8. And the get this on the edge. This is kind of standing up when it's in the unit. Well, No, it's laying down. It's laying down. It's laying down in the unit. But we're gonna turn it this way, and just pull it out a little bit so it's not on my thing too much. These little lightweight batteries, they're so lightweight. I could hang it, but I'll just bring it up here, sit it on top. It's not gonna be on very long. We're gonna take our regulator and connect it to our tank. And we're gonna hang that down because it's a, so the vent is down. Normally I have my table doing this, but I'm just doing this quick and dirty. All right, let's turn the gas on. Grab a wrench out of the truck to the gas bag here. And we'll use the Vera. Tighten this up. I can smell it. I like this. This is a slip wrench. And if you've ever had to do this when this fitting is right there, you have to come through here. And it takes a very long time if you don't have one of these. So get yourself one of these. This is the Wera, the 2419 size. The Wera Joker. It's basically a slip wrench. All right. So now that we got the gas going, got that on, we got the power hooked up. Let's make sure our switch is on. In here, only things left is a thermostat. I used to just twist these together, but I've had problems with that, so now I use a real connector every time. Did not ignite. I know my cell switch was up. Let's see what's going on. Time to troubleshoot. Let's see what's going on with this. Let's turn it off. That's pulled tight. I can't go any further. No, the switch is good because the power's starting. Everything's connected properly. My igniter's connected. My gas is on. Hey, what's wrong with this thing? Turn it on again. Let me check the power on this thing. All right, just had a little air in the line as far as the gas on the second try. And I did what I said I don't like doing, just to make sure I was making a good connection. I took the thermostat wires out, straightened them out, and then I just touched them together, and it lit up very fast. So now normally you need to have the little separator on here so the intake isn't taking in the fumes, or a lot of times the furnace won't run like that. This one is doing okay, but typically I like to have the thing on it. But now that I know this furnace is going to run, I can take this back to my customer. Now I'm going to disconnect the thermostat, Okay, so now that's behaving properly. The flame went out immediately, but the fan is continuing to blow for our cool down cycle. That's how it should happen. I've seen some anomalies in some dinosaur boards to where it will shut off immediately, and then after I cycle it a few times, it's like it starts working properly on the fan 50 plus pin boards. But I've always gotten it to while I'm bench testing it, I do it a couple times, and it's like the board kind of figures out what it's supposed to be doing, and it starts going through the cool down cycle. Okay. Well, that's going to be a win, guys. The new blower motor is doing great. You can see that cell switch. It's kicked back. It's just that motor just wouldn't spin fast enough to blow that cell switch. It's the only part we change. It's the same board. Everything else is the same. So let me get the customer on the line, let him know that his furnace is working. I typically like to let these run for 10 minutes. The only reason I'm not doing this one for 10 minutes is because I had to leave the pipe in the camper. There we go. Because I was taking the unit and he was going to be out of service for a couple of days. And to keep the air from going in, I left the pipe there because I knew if I had to, I can just find some old duct work, put onto this one, just route it down so that it's intaking nice cold air, not the hot air. But like I said, it's not having a problem out here with this one. So that's good. So that's a fix. I hope you guys got something out of it, my technicians, and anybody else who's just interested in stuff. I like to watch stuff that I don't plan on doing. Like I watch a lot of those YouTube videos with the guys that are building the watches, taking watches apart, mechanical watches, and I just love watching them take apart the motion and everything. And I'll never do that, but I love watching them do it. So I hope that this was interesting for somebody, and maybe it'll help you out. Maybe you can help somebody else out. If not, if you're in the area, just call us and we'll come by and sort you out. All right, let's take a look at some of the tools we use to get the job done today. DeWalt DCF 801. Always that little small 12 volt. It's so super light. I got the 3 amp hour battery, so it's as small as a 2 amp hour, but I get more runtime. Fits in the bag better than the 5 amp hours. We used the AES wave kit for the first time. Used it to feed power. Now you can't feed power with the back probes. Like there's like these, the back probes. That's too skinny. But all these other leads, you should be able to send power. So that furnace works off of between 7 and 9 amps. It handled it fine. Let's take a look. I don't have any burn marks, no melting on the gator clips. Looks good, and that's what I needed to do, because if it can't handle up to 10 amps, it's garbage. All right, we have the Icon tap and die set. It worked, guys. The Makita beast of a hammer drill, GPH01. This is the kit for the handle. I put it on so tight I couldn't ever get it off, so now I'm just stuck with it on there unless I want to cut it off. And I say, oh well, I just leave it on there. And I just screw the handle on. I could probably put it in my vise and do some stuff to get it off, but so far I hadn't worried about it. If I do get it off, I'll probably end up destroying the threads. Would have been nice if they made the inside of that part a hex, so if you did get it on too tight, you could take an Allen key and back that back off. So Makita, anybody who has any clout with them, suggest that on the next design of this thing. Make the inside a hex so that an Allen key can take this apart. Okay, then of course my bit sets, my Vito Pro Pack bags, We got the, this is the, what is this thing? The MB3 blackout, and all the tools that's in it. My diagnostic bag, which I use all the time. Here's the box if you want to see it, for the Icon tap and die set. It held up better than the Irwin, guys. That one tap, and it did the job better. So I was much happier with those. Just seems like the first few threads or so, like on this Irwin, it just rounded them. It's like it just mushed them, bro. Allen keys, these are not Lang, but Eklund. This is out of my Eklund kit, and it needs to go back. Didn't have to use these test leads, but if those wasn't gonna do it, I know I have some inside my my TR whatever little bag that holds my little test leads. This is normally on my electrical bag. I knew it would do it. And you saw the stuff outside that we use as far as for the bench testing. Very important. And last but not least, how can we forget the underrated tailgate? Everybody, maybe not everybody, but most guys that I know who work out of a truck, we work off this tailgate a lot. It's like the quickest table you can flip out. You flip down that tailgate, load your tools out, do stuff on it, work on it, and you know, sweet. I need to get my drill back into this box. I've had these boxes for half a decade, guys. They're still going strong. I bought them one time, man, the DeWalt boxes, and back when I bought them, they were like $120 for the whole stack, with the wheeled box and all. Great value. They hold up, guys. They're bounced around in this truck all day, every day. They still are watertight, and I don't have a problem. I used to take them in and out every day going to work when I worked at John's RV. I rolled them in and out. So they've been through their paces, and they've held up awesome, guys. Totally recommend them. That Mac Tools box, I can't recommend it because that part breaks. These little clips, they're supposed to snap into the top, so when you first open the box, those little parts stay up in the lid. It might have worked. It might have lasted about a year. I got about a year out of that before that was broke. Yeah, so, but these DeWalt Tough boxes, these are the bee's knees, guys. Hadn't had a problem with these drawers either. This is a newer addition. The drawers hadn't had a problem with them, the rollers and everything, and I got them overloaded. You know, everything I got gets put through the paces. I got them overloaded. I got way too much weight in them. They work. Let me get out of the cold, guys. I'll catch you guys later. RV Tech Pro.